Okay, so we need some review on simplifying radicals. So if you have the square root of something times something, you can change it to the square root of that thing times the square root of the thing. It doesn't work with adding and subtracting. Just for the record, the square root of a plus b is not the square root of a plus the square root of b. It only works with multiplication and division. It doesn't work with adding and subtracting. So do not, I don't think we're going to do that for a little while, but let's go ahead and put that out there now. So what we're going to do, if we need to simplify the square root of 72. I think you guys have done this before in both geometry and algebra 1, but we'll look at it here. What you're going to look for, the easiest thing to do is find a factor of 72 that is a perfect square. So that's why you should know your perfect squares. If you divide 72 by 2, you get 36. So you can think about 36 as a perfect square. This is the square root of 36 times the square root of 2. And the square root of 36 is 6. So it's just 6 square root of 2. Now, if you're not sure, you can't, find a perfect square, just start asking yourself what multiplies to 72. It's also 9 times 8. So the square root of 9 times the square root of 8. Well, you know the square root of 9 is 3. But now you can keep going with the square root of 8. What is the square root of 8? What it multiplies to 8? 4 and 2. Well, the square root of 4 is 2. And so now you do 3 times 2 and you get 6. 6 square root of 2. Same thing. So one like this, 432, may not be as easy to break down, so you just try some things. Now, I divided it by 3. You can divide it by 2, and you'll see what 432 divided by 2 would be 216, which is not a perfect square, but you could break it down again from there. You could check 4. 4 should go into it. We'll try different things here. 144 is a perfect square. It's 12 squared, so the square root of 144 is 12. So 12 squared to 3. Again, you can try other things. 4 plus 3 plus 2 is 9. So 432 is divisible by 9, so you just try it. Turns out it's 9 times 48. And square root of 9 is 3. So what goes into 48? Well, 16 goes into 48. We also know 4 and 12. You can try all sorts of different things. 4 is a perfect square. So the square root of 4 is 2. Back up, sorry. But 12 also has a perfect square in it. It's 4 times 3. And again, the square root of 4 is 2. So you have 3 times 2 times 2, which is 12. So just keep breaking them down by perfect squares. 4 is a perfect square, 9, those small ones, you just have to keep breaking it down. 24 is an easy one. I'm going to have you try that one. Work that one out real quick, pause it, and come back and check your answer. Okay, pretty simple. 24 is 4 times 6. The square root of 4 is 2. 6 is 3 times 2, and that's all. And there is no perfect square in there, so that's it. 2 times the square root of 6. That's going to come up as we go here, because now we're dealing with things that aren't perfect squares anymore. We're not even going to be doing any factoring with these problems. It's just a different style. Okay, so one of the problems that come with, I think we've talked about this a bit in class. So if x squared equals 9, I think most of y'all would tell me x is 3. But there's another number that when you square it, also gives you positive 9, and that's negative 3. Now, normally we could write x equals 3 and x equals negative 3 as our two answers for this. We just have a shorthand version of it. We put the plus and minus in one thing. That means x equals positive and negative 3. You're giving two answers, but you're just giving it in one line. So if x squared equaled 2, it's not a perfect square, but we would just take this, we took the square root of 9. So we take the square root of 2, but we need to take the positive and negative. So again, just for the record, your answers are actually x is the negative square root of 2 and x is the positive square root of 2. All right? So over here, this looks like it's a difference of squares, but 24 is not a perfect square. So the last one we said, let's set everything equal to 0. Well, this one, let's go ahead, since we just have one term. Let's go ahead and move 24 to the other side. And now, x is going to be the positive and negative square root of 24. Well, remember, we simplified this. The square root of 4 times the square root of 6. So 2 square roots of 6. So x is plus or minus 2 square root of 6. Okay, let's kind of put it all together here. What you want to do is when the square is on the outside like this, you want to get this thing by itself. So we're going to divide both sides by 4. Now, to undo the square root, undo the square, I square root both sides, but I have to do the positive and negative square root. The square root sign cancels that part out. So I get x plus 2 is the positive and negative square root of 6. So then, just like any algebra problem, I want to get x by itself. I subtract 2 from both sides, and that is my answer. This is how delta math will take it. Again, what you are saying is x equals negative 2 minus the square root of 6, but x also equals negative 2 plus the square root of 6. Okay, try to work this one out, pause it, come back and check your answers. Okay, again, I want to get this parentheses thing by itself. So I'm going to subtract 27 from both sides. Now I'm going to divide by 2. Now I'm going to take the square root of both sides and get that x plus 7 is the positive and negative square root of 7. And then I'm going to subtract 7 from both sides. It's about time for class to start, and there we go. Okay, let's run through a couple more here real quick. Try this one on the left. Pause it and check your answers. Okay, so we add 23 to both sides. We divide by 5. Take the positive and negative square root of everything. I'm going to add 10 to both sides. And then simply I'm going to divide by 2. And the nice thing is, you get to leave it just like that. 11 can't be broken down, so we're all good. Next one here, everything's by itself already, so I'm going to take the positive and negative square root, and the nice thing is 9 is a perfect square. So now I'm going to add 4, and then I'm going to divide by 2. Well, the thing is, delta math is going to want you to actually work this out since it's not a square root anymore. So we do 4 minus 3 over 2, and 4 plus 3 over 2. Very simple. On the left, we get 1/2, and on the right, we get 7 over 2. Delta math will just, as soon as you type 1/2, and then you put a comma, and it will pop open a new box for you, and you put 7/2. Okay, this one's a little different because the square is on the inside. All you're going to do is do the distribution. You can then combine like terms. If you had subtracted 11, the problem with this would have been if you had subtracted 11, we'd have gotten 9 over here. Your instinct might be divide by 4. Not bad. You're going to get 9 over 4, and it's not going to be a thing that too bad, but you're going to have to do some adding, subtracting there that might get a little nasty. So notice that like not everything is divisible by 4, so don't try. So here I can combine the 72 and 11. And now I can add 61 to both sides. And now divide by 4. And the nice thing is now when I take the positive and negative square root, I've got 2 nice, neat, perfect perfect squares. By the way, for the record, it's the square root of 81 over the square root of 4. So you just take the square root of each number. It's positive 9 over 2. Pretty sure it's going to make you in delta math type 9 over 2, comma, negative 9 over 2. Okay, there you go. Good luck.